Good morning, ladies and gentlemen. We're going to do 13.1b today. We're going to be talking about indirect measurement. So we're going to use our right triangle trig and then indirect measurement to find the heights or lengths of objects that are difficult to measure. So a couple of vocabulary words as we get started. So let's say I have a human, lovely human, don't laugh at my artwork, and the human looks at another human standing on top of a hill. I guess I shouldn't quit my day job, huh? All right. As this human looks across, this line is called a horizon line, okay? And it goes forever. This human up here is looking this way, and this is also called a horizon line. You'll notice in theory that these two lines are actually parallel, okay? And I'm going to just extend that little line just there for a second. So because those two lines are parallel, this angle and this angle are congruent because of alternate interior angles, yay geometry, of parallel lines, okay? This angle is called the angle of elevation. Alrighty, and then this angle up here is called the angle of depression. So we'll notice that the angle of elevation and the angle of depression are actually equal. So the other thing that I need to point out is a very common mistake. This angle is almost never used, which is why I put a big red X on it. These two angles are complementary, which means they add up to be 90 degrees because we assume that things are going straight up and down until later in the chapter. So because they're going straight up and down, these two angles are complementary, meaning that they add up to 90. Oftentimes what students do, though, is when they're drawing their diagram, they label the angle of depression and put it here. That is not the angle of depression. The angle of depression goes from the horizon line down, and it is congruent to the angle of elevation that goes from a horizon line up. Okay? All right. So the process of indirect measurement, we use it to measure things that are difficult to measure because of their size oftentimes. So, for example, I might want to measure the width of the Grand Canyon, or I might want to measure the width of a river or the height of a building. And so I can use a process called indirect measurement to do that. All right, so I have a couple of word problems already written down, and so we're just going to start working through those problems. The first step in these is always to read and then draw a diagram. So here's our first problem. A parasailer is attached to a boat with a rope 300 feet long. Parasailer, those are the guys that are kind of cruising along up in the air behind a boat. The angle of elevation from the boat to the parasailer is 48 degrees. Estimate the parasailer's height above the boat. So the first thing that we always do is draw a picture. So here is my spectacular artwork. I know it's a motorboat, but that's easier for me to draw. We'll give some water. It's lovely. So I have a rope attached to a human cruising along up here. Okay, so my human's holding onto the rope. Okay, and then he's got a little parachute chilling out back here. What would a parachute look like? Oh, there we go. Whoop, 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 whoop. There's my parachute. How's that for spectacular artwork? All right, we know that in theory it's a right triangle. There's 300 feet of rope from the boat to the parasailer, and I know that the angle of elevation is 48 degrees. And then my task is to find the height that the parasailer is above the boat, okay? So I don't have the horizontal distance, so what I'm going to use is sine because it's opposite over the hypotenuse. So if I do my math, I would say the sine of 48 is equal to h over 300. Okay, remember this is in degrees, so our calculator's mode is going to need to be in degrees. I'm going to cross multiply. So I'm going to get h is equal to 300 sine 48. And let me get out my handy dandy grapher, okay, just to make sure that we can enter that correctly in our calculator. I'm going to check my mode. Okay, so notice that mine is in degrees, not radians. We'll talk about that in a day or so. So then I'm going to do 300 sine 48, and I get that the height above the boat is 222.943 feet. That would just scare the bejeebers out of me. All right, there you go. So that's not a difficult process. Oftentimes getting the picture is the hardest part of the problem. All right, so now let's move on to our second example, and I actually drew the diagram already because it was given in this problem. It says a tree casts the shadow shown. What is the height of the tree? Okay, so again, we assume that the tree is straight up and down. Here's my shadow, it's lovely. I know that the angle of elevation from the ground to the top of the tree is 31 degrees, and the distance of the length of the shadow is 25 feet. So I want to find the height of the tree. Well, in this case, I don't know what the hypotenuse is. So that means I'm going to use tangent. So I would say the tangent of 31 is equal to the opposite over the adjacent. Solve, I'm going to cross multiply, and I get h is equal to 25 tangent 31, and I'm not going to show you that in my calculator this time because I'm assuming at this point that you can do that. Okay, so I know that that math, when I do it in my grapher, is 0.22 feet, so my height is 15.022 feet, so that's the height of the tree. Alrighty, super short video today. I did a couple problems for you. We will do a worksheet in class. So let me give you your problems. Sounds kind of nice. Super simple. Alright, here's your first problem. Again, don't you love my glorious artwork? Alright, it says the Falls Incline Railway at Niagara Falls has an angle of elevation of 36 degrees. The railway extends a horizontal distance of about 138 feet. Find the height and length of the railway. Alright, so here's my train. Here's the 138 feet. This is the 36 degrees. I want to know the height of the falls, or the height of the railway, and then I want to know how long the track. So I actually have two different measurements that I'm going to need to find. Okay? And I definitely should not quit my day job because my artwork is a little bit cheesy. Your second problem, you get no diagram. On this one, you have to draw your diagram. It says you're climbing Mount Massive in Colorado. You're at an altitude of 11,200 feet. So this means this is the distance that you are starting. That's the elevation or the altitude where you start climbing. You measure the angle of elevation to a ridge above you to be 29.4 degrees. The distance along the face of the mountain between you and the ridge is 63.15 feet. Find the altitude of the ridge. Okay, so you're going to get to draw your diagram on this one and then solve the problem. And I would just give you a hint as you check your math. The peaks in Colorado tend to be very tall. All right, good luck with your math, and I will see you tomorrow.